Hello, I am Dave Ackman of the Gateway Division of the National Model Railroad Association, and I'd like to welcome you to this seminar on automating computer-aided design for 3D printing of model railroad structures using a technique I call generators. Model railroading is fun, and creating 3D printed objects for model railroading structures is a lot of fun. But learning how to create 3D models with computer-aided design software, also known as CAD, is not fun. It's frustrating. CAD software is complex and requires a level of manual dexterity and patience that few of us have. But when it comes to creating components for model railroad structures, there can be other ways. Today we are going to explore how we can use personal computer programs I call generators to fill out forms and generate 3D models to our specifications. We are going to automate the CAD process for model railroad structures. I promise to show you how to download these generator tools for free and not to make you learn a bunch of programming mumbo-jumbo. Scout's honor. Here are some of the structures that you are going to learn to create. Here is an A-frame cottage. You are going to learn how to create shake shingles, the foundation, and deck. Could your layout use a log cabin or a hunting lodge? A generator can help you create one. Here is a freight house with board and batten siding, scalloped roofing, and a loading dock. And speaking of docks, would you like a place to do a bit of fishing or park your boat? Do you wish there was a way you could design your own custom windows? There is a way to do that too. So, how do we do that? We start by visiting my website at http://daakm.github.io and scrolling down to the Automating CAD Clinic. After a brief explanation of the concept, a sample of a generator screen appears, this one for creating shake shingles. The screen consists of fields in which you enter configuration values and make option selections. Further down, we see what the resulting model looks like. Finally, we come to a table showing all of the generator programs I have created, along with some I plan on creating in the future. Just above the table is an explanation of how to download the generators, so just click where it says "Click here." A download screen appears and you click on the download button at the right. A zip file will be transferred to your download folder. It may not be obvious that the download has taken place, but just click on the downward pointing arrow in the upper right, and if you see a file labeled automatingcad.zip in the pop-up window, then the download was successful. Depending on your browser, you may get a pop-up saying the file is not commonly downloaded and may be dangerous. Well, that's true. This file is not commonly downloaded, but if you want my programs, you are going to just have to trust me. So click on the arrow and keep the file. Once the file is downloaded, open your Downloads folder and double-click on the automatingcad.zip file. You will see a list of generator executable files. I suggest that you create a new folder and extract them all to this new folder. Then use your virus scanning software and scan the new folder. Or you could just double-click on one of the executables to launch it straight away. The first time you attempt to launch a generator, Windows Defender may try to block the program because it does not recognize me as a commercial software publisher. No matter, just click on the More Info area and then on Run Anyway, and the generator will launch. You only need to do this once for each generator program. When you launch a generator, a design screen appears. You enter the parameters of a design you would like to create. Here we have the generator for a basic building. You can create a building with flat walls, clapboard siding, logs, or boards and battens. We specify the size of the building and the roof line. For a log cabin, we specify the diameter of the logs we wish to use, how closely we wish to overlap adjacent logs, how to offset the corners, and then we click the green button to generate the specifications for the model. No doors or windows in the structure just yet, but we will cover that shortly. Notice that I did not say we are going to create the actual model, but are creating the specifications for a model. To go that final step, I'd like to introduce you to a CAD package you may not have heard of called OpenSCAD. OpenSCAD is a free package in which you use a programming language to describe a model you wish to create. You can download a copy of OpenSCAD from http://www.openscad.org and follow the installation instructions. The language is a bit complex, but I learned how to use it, and my generators take your specifications and produce OpenSCAD input files for you. All you need to do is load the generator files into OpenSCAD, render them with the F6 key, and save them as a stereolithography file, a 3D model. You then have a model you can print immediately or enhance further with a traditional CAD package. I have done all the programming for you. All you need to do is design, convert, print, and enjoy. Did you get all that? Okay, it was kind of fast, so let's go over the theory once more. But remember, there is a handout on my website with all the details in writing. We start by visiting my website at http://daacom.github.io. Then go to the Automating CAD section, click where it says Click Here to download a zip file containing the entire collection of generators, and download it. We then either extract the entire collection to a new folder or double-click on a specific executable file to launch it. If Windows Defender objects, we click on More Info and then Run Anyway. I run Malwarebytes and Windows Defender, so I'm doubly protected from viruses. But for your own peace of mind, you should scan my generators once downloaded, just to be sure. Once you launch a generator, change some of the parameters just for grins, and then click on the green Generate button and specify the name of a file. The extent must be .scad. After you have downloaded OpenSCAD from openscad.org, launch OpenSCAD and open the SCAD file you just created. A quick and dirty image will appear. We will cover how to zoom, pan, and rotate in OpenSCAD in a few minutes. But if you generally like what you see, hit the F6 key to do a fine rendering. This can take several seconds to a minute or so, and while rendering, the rough image will disappear, so be patient. When the tone sounds, click on the STL icon and save the object into a stereolithography model file. Simple, right? Well, maybe not. I'm going to assume you were successful in downloading OpenSCAD and a generator program, got past any security issues, and are ready to go through the modeling steps again in a bit more detail. Let's give it another try. Let's start with the A-frame, specifically the shake shingle generator, which was the first generator program I developed. I wanted an A-frame structure, but was unwilling to glue paper or thin wooden shingles to a substrate. I just don't have the patience or the manual dexterity. But I do have a 3D printer. I observed that shake shingles are nothing more than rectangles of slightly differing sizes attached to a substrate in straight lines. They are of slightly differing thicknesses, but are shaved to a common pitch angle. I knew I wanted to specify the horizontal length of my roof, but instead of specifying the vertical height, I decided to specify the number of rows of roofing I wanted and their vertical offset, which would define the total height of the roofing panel. I collected all of these design requirements into a generator program. I added a green button to do the math to produce the .scad file for OpenSCAD. I also created a red button to exit the program and other buttons to reset the parameters to their default values. I like to think that the default values I chose were good starting points for most projects. And finally, 2 buttons to save and reload modified design parameters into configuration files as I iterated my design. There is also a notes window where the generator program can provide information to you. Let's run a sample with the default values and send the .scad file to a folder. I am going to launch OpenSCAD and do a file open to select the file the generator created. Almost immediately, a rough approximation of the model appears. You can press, hold, and move the left mouse button to rotate the model. You can use the mouse wheel to zoom in and out. You can press, hold, and move the right mouse button to pan. Finally, you can use the F6 key to render the model. Rendering can take a bit of time, perhaps 30 seconds for a model with 100 shingles like this one. And while rendering, the model display window will erase in preparation for displaying a higher resolution image. When a tone sounds, the render will be complete and you can press the STL icon to create the stereolithography file, ready for printing. Let's repeat these tasks, this time creating a basic building. Let's build a clapboard structure for a freight house, and let's make the ends in a peak of 30 degrees. We will save the parameters in a configuration file, in case we ever want to get back to this model and make modifications. And then click on the green button to create the SCAD file. We then launch OpenSCAD and import the freight house. The initial import is promising, so we use the F6 key to produce a detailed rendering and then click on the STL icon to produce the model file. You could go directly to your slicer software and print the freight house. I use an Ender 3 Pro 3D printer, and at first that is what I did. The downside would be that the building would have no holes for windows and doors. But that is where just a bit of knowledge of a traditional CAD package can be extremely useful. I am going to teach you just a few very basic techniques in a free CAD package called Tinkercad, which will prove absolutely indispensable to bring these primitive elements into really useful models. And we are going to take less than 6 minutes to do so, hopefully with even less pain than a COVID-19 injection, even if you have never used a CAD package before. I promise I will be gentle. Here's what you need to know. How to import an STL file into Tinkercad. How to rotate the model view. How to zoom the model view. How to pan the model view. How to add a hole to a model for a window or door. How to resize a hole or model shape. How to align holes or shapes. How to rename model files, and how to export a model for 3D printing. Tinkercad is a web-based application, which you can start by visiting http:// www.tinkercad.com. tinkercad.com from your web browser. When you do this for the first time, you will need to create a Tinkercad account. But since this is far from my first time using Tinkercad, I go directly to the main screen. To import our freight house, we click on the blue and white button to Create New Design. The design screen appears, and we click on the Import button in the upper right. The Import Shapes box appears, and we click on the Choose a File button and select the STL file that OpenSCAD has created for us. Tinkercad does allow us to alter the scaling of the model, but since we specified the dimensions to our liking in the generator, we just click on the Import button, and after a brief delay, the image appears on the screen. Now for some instructions on basic navigation. To rotate our viewpoint, we just hold down the right mouse button and move the mouse. To zoom in or out, we just rotate the mouse wheel. To pan up, down, left, or right, we press and hold the mouse wheel and then move the mouse. Pretty basic stuff. Next, let's add a hole in a wall for a door. A standard door is 80 inches tall, or 23.32 millimeters in HO scale. So let's add a hole to the front wall. To do so, we click on the gray cube shape and drag it to where we want it, and then release the mouse. The default size of a shape in Tinkercad is 20 millimeters on a side, so we need to alter the size of the hole. I want the hole to be about 2 millimeters smaller than the door, so I click on the black squares on the edge of the hole shape to make a dimension box appear. I then click on the box and enter a new value for the length, depth, or height of the hole. Arbitrarily, I'll make it 15.5 millimeters long, 5 millimeters deep, and 21 millimeters tall. I probably will need to reposition the hole after resizing it, which I do by dragging it into a position I like. Once done, I group the hole and the building to complete the task. To do so, I lasso both the building and the hole to select them both, and then click on the group icon to complete the operation. If at a later date you wish to move the hole, just select the building and click on the ungroup icon. Let's give this technique another try and add 2 holes for windows. Now let's add a rectangular hole and then resize the hole to 10 millimeters wide, 15 millimeters tall, and 5 millimeters deep. We can also use the black cone tool to raise the hole 6 millimeters above the work plane. To make a duplicate of the window, we use the standard Windows operations of copy and paste and drag the window holes to a desired position. Now, just for grins, I'm going to move one of the hole shapes and show you how to get them back in alignment. To align the window holes, I click on one and then shift-click on the other to select them both. With both holes selected, I click on the Align tool and select one or more of the align points. I group the window holes with the building and then have holes into which I can snap my windows. With my 3D printer, I often need to make my holes 0.75 millimeters wider and taller than the actual windows, but your mileage may vary. Tinkercad gives our model files funky names, and I like to rename mine by clicking on the name and entering a new value. Finally, to export our modified freight house, we click on the Export button, and Tinkercad places the modified model to our Downloads folder, from which we can direct it to our 3D printer following our manufacturer's directions. There are many other tools and tricks in Tinkercad, and if you want to learn more, take a look at YouTube for tutorials. I particularly like the 6-part series by Promo Ambitions. Now, Back to the generators. While every building needs a roof, not all must be made of shake shingles, and we have a generator for roofs too. We just specify the dimensions and the type of roofing desired. Here we are generating one roof panel with semicircle shingles, and another using the option to bevel the top edge. There are two ways in which a pair of roofing panels can be joined. One way is to print a pair of unbeveled panels and sand the top edges to an appropriate angle and glue them. The other way, which I prefer, is to select the option to bevel the edges, making sure the roof angle matches that of the building where it will be used. In CAD, I rotate one panel to its side, raising the edge back to the surface with the D key, and make a copy. I flip one of the panels, change my grid resolution to 1/10 of a millimeter, and abut them at their peaks by hand. I use the align function to align their front and top edges and group them, after which I print them as a single object. I like to rotate the combined panels into a vertical position for printing, and usually use a brim to adhere the roof to the build plate of my 3D printer. At this time, shake shingles do not offer a beveled top edge option, but I expect that option to be available by the end of the summer of 2022. Am I on to something here with these generators? What about a brick wall generator? I can specify design parameters for the entire wall and the individual brick sizes. I can specify the size of the mortar runs and how far I want each brick row offset. I can specify if I want the edges to be flush or ragged. But there isn't much difference between a brick wall or a wall of construction blocks or a wall of field stones, just the dimensions. And I even provide some comments at the bottom to remind me how I might change them for HO scale. They look pretty nice. I just couldn't stop. A generator for frame windows was next, and the specifications for these were quite a bit more complicated. The first row of parameters specify the hole size for the window. Again, my printer tends to deposit a lip a bit where the filament first hits the build plate, so I usually make the holes in the wall 0.75 millimeters wider and taller than the windows which I will insert. Your mileage may vary. Windows have frames, and frames have widths, and there may be more than one window unit in the overall window. Individual windows have one or two sashes, and sometimes we might want to raise the lower sash. And sashes have mullions. Windows may have upper and lower pediments, and these have dimensions and styles. Of course, you can design windows as you see fit, but my website has several parameter files that closely approximate the designs from Tichy and San Juan, aka Grantline. The hits just keep on a-coming. My A-frame needed a poured concrete foundation, so I created a generator for that next, complete with cutouts for windows. And I bet you have an idea how I created the windows. And after the foundation, I just had to have a generator for a floor for my A-frame. A floorboard 1.8 millimeters wide is equivalent to a 6-inch wide board in HO scale. A bit wide, but acceptable. Floors are really similar to decks and docks. Perhaps sometime in the future I may enhance this generator to create railings. Eventually, I plan to create documentation detailing how all the design options work. But until I do, I hope the field descriptions are sufficient. The generators are free to use, but I am not available to debug your designs, and the underlying code is copyrighted, so don't ask for it. Like all new computer programs, there may be bugs, and if you find one, or have an idea for an enhancement, let me know. A link to my email is at the top of my website. But you are explicitly permitted to use these generators for structures on your model railroad. I also promised that this would not be a clinic on programming. But if you are a true computer nerd, here is 3 minutes of the basics. Otherwise, close your eyes, relax, and come back to life when I blow the whistle. I started by loading Visual Studio 2019 from https://visualstudio.microsoft.com/vs/older-downloads. And there are YouTube videos that show how this is done. You will need a Microsoft account to log into the download server, but accounts are free, as is Visual Studio. Newer versions of Visual Studio are available, and they work as well. Once downloaded, I start Visual Studio and click on Create a New Project, then on Windows Forms App.NET Framework, the Next button, and finally I give the project a name and click on the Create button. Anytime I want to return to an application, I just launch Visual Studio and select the project of interest from the initial splash screen. Now, it's just a matter of adding text boxes, labels, buttons, and code. The first thing I do with any new project is create an Exit button. I open the toolbox and drag in a button and give it some configuration properties, changing its color and text. I double-click on the button and add the End line of code, so that when the button is pressed, the program will end. To make the program run, I just click on the Start button. And if I get into an endless loop, I can always close the program from the taskbar and correct the problem. In Visual Basic, the message box statement can be a useful debugging aid. Adding a data entry box is similar. I drag in a text box and place it on the form. Note that a text box will have a name, something like text box 1, and you can refer to its contents by using textbox1.text as a variable. If you want to see if the box contains a number rather than text, use a function like isNumeric and the cdec function to convert a text value to a decimal number you can use in computations. Labels are even easier to add. Just drag in a label control from the toolbox and alter its text value as needed. I usually add another text box which I call Notes, and this area is to display general information. Here I am adding another command button which will display the time of day in the Notes area whenever the Clock button is depressed. If you want to read and write files, you will need to add the Open File dialog and Save File dialog boxes to your project. From time to time, I save the project by clicking on the File, Save All command. There is also a button that does this as well. The real joy comes in making the program do something useful. I create an additional button and insert all the code that does the real work behind the green Generate button. It ain't that hard, but it ain't that simple either. I have been writing computer programs since 1966 and have a master's degree in computer science, so coding comes easily for me. Perhaps you have a grandchild who can assist. That's all the help I'm going to give you. It's probably more than you really wanted anyway. I'm certain there will be more generators appearing from time to time. Shutters, louvers, trestles, stairs, and canopies will be added in the upcoming few months. Existing generators will be enhanced. For my part, I do hope you take away from this clinic access to new tools for producing 3D structural models. And if you have a programming background, particularly in Visual Studio and Visual Basic, I hope this clinic might inspire you to take the concept of front-end generators in another but similar direction. Generators for freight cars? Anyone? Remember, when it comes to designing 3D models, necessity may be the mother of invention, but frustration may be the father of the twins, imagination and innovation. Thanks for your attention.